So let's get started. This is about everything about code signing and, and how not to use it. So we have also some bad examples that unfortunately are still the reality. So my name is Raimund. I'm working for Microsoft Germany since quite a long time. My focus is everything around PowerShell and DevOps. And of course, we want to first thank you, our sponsors. So the agenda for the next 45 minutes is why should we do code signing? What are the code signing basics when doing it locally, when doing it with Azure Key Vault, and when doing it in a fully integrated release pipeline, which should be the goal finally. And let's first discuss why we should use code signing. By the way, first the question, who is using code signing already in your enterprise organization? For internal resources or for software that you deploy and distribute to other customers? Internal. And what's the reason? Trust. Okay. Okay.
So it is. The idea is that you can set up your servers so that you can secure your servers better, and then when you deploy code to them, they will only run signed code.
Okay. Yeah, that's the common use case. How do you sign your scripts?
I have a certificate that makes a big blob of text at the bottom.
Okay. So this is the technical background. But what is the process of signing the script? Okay. Why are you here? Yeah, but unfortunately, I know many organizations that still use it the very old way with the commandlet. Okay, so first of all, let's have a look. Why should we be interested in code signing and why? And who should be interested? Of course, software vendors. They have the biggest pressure of code signing because they distribute software to the outside world, which needs to be trusted. But also IoT manufacturers, mobile app developers, and of course the enterprise IT. And I think most of you are dealing with internal IT, so the enterprise IT. And there are some interesting quotes. Why do we use code signing? To protect intellectual property, company brand, and the end users. And code signing works, but poorly implemented code signing puts your business at greater risk because you're telling something about trust and security which you may not really create when you do it the wrong way. Okay, so what is still the reality, unfortunately? I had the discussion just about 3 weeks ago, right? We want to prevent users from running scripts. We have heard that code signing and PowerShell execution policy can help us achieve that. We have already got a signing certificate from the PKI guys and put it on the admin share. It works perfectly. Does it? What's wrong with this assumption? The assumption is, the main problem here is that they put the certificate on an admin share, and that's the most crucial part in a signing process. So if the certificate is available for a handful of people, you never know where this is going to get next. Maybe it's not going to remain on the admin share, it's being copied to some more available share, and then your whole trust chain is so unsecure and so unreliable that you don't create trust, you have a negative trust impact, right? And unfortunately, this is still how many companies still work. And there is another interesting fact about who's using who's using the PowerShell execution policy on the machines. For what purpose? What do you think is the main purpose of the execution policy? What was the idea when inventing it? Yeah, but is it a security feature?
No, it's to help people from not hurting themselves.
Yes. It's only a measure to not make mistakes, right? But it's not a security measure. And still some people think that it is. And there is an interesting article, 15 ways to bypass the PowerShell execution policy. Not just 1 or 2 ways, 15 ways you can get around it. So obviously it's not the right way to go. Okay, so what is code signing? Code signing should verify the software origin, if you do everything correctly, right? It ensures the code integrity, not the quality, right? It only assures that the code has been created by the authenticator or by the authority you think it is, using hopefully a predefined and robust pipeline. It enhances the user experience and trust. Well, it's much easier to download something that is already trusted. You don't have to answer a couple of security warnings and questions. Combat malicious attempts, of course, because it is signed, so anybody who is trying to tamper with the software is breaking the signature, hence it's no longer going to run. Yeah, these are the things. And what is code signing not? What is it not? So, it does not fix coding bugs. And sometimes people still think if it is signed, it's guaranteed to run, it can only do its job. No, that's not true. It does not guarantee software quality. It should guarantee the code's authenticity and the author, but it does not always do. And if you do code signing the wrong way, you are in a very extraordinary league with these names here, right? Because all these companies have lost their private code signing keys to attackers. And you can see by the numbers that it's not very cheap to lose a code signing certificate, right? So then the question is, what happened that these companies, which are usually quite trustworthy, lose their most precious asset in a code signing process? What went wrong? And this is the session about. It's about what do we need to do to prevent these kind of things. And nowadays it's quite easy to prevent that. Okay, so how does code signing actually works? That's the very basics of it. We don't go into cryptography and all the stuff. We just show the process, keep it simple. And the code signing flow is that. First of all, you have your file that you want to sign, the PowerShell script. Then what we do is we're creating a hash, a digest of the script. And this digest then is taken by setAuthenticateCode signature. setAuthenticateCode signature accesses the private key, generates the signature, and hopefully also a timestamp, and adds that to your script. And you've all seen that, I guess, right? You have your script file and then as a comment block, the signature of the script. So, quite easy. Who has not used setAuthenticateCode signature in the past? Okay, then let's go into a very short demo, how this works, and don't do that, right? So, it is for testing purposes quite okay, but it should not be done in a professional IT environment. So, let's go to the demonstrations, and by the way, all these scripts are available on GitHub. The link is at the end of the slides. So here we have our local signing script, and what we do is, first of all, we generate a certificate, right? So we define a couple of constants, like what is my certificate name, where should it go to, what's the path, what's the password if we want to export it, and the timestamp. And then we can create a self-signed certificate. And, oh yeah, access is denied. I need this as an administrator. Just because I put the certificate on the local machine branch. Okay, once again, define these variables. As soon as the add-in is ready, here we go. Create the certificate, move it to local machine root. And then we want to check if we really have a private key. So if you do a getChild item on your certificate path and you use the switch code signing certificates, you only get code signing certificates that have a valid private key. All the other ones are filtered out by default. So let's see. What do we have in here? There it is. Do we have the private key? Yes, we do. So and then we can simply use that certificate to encrypt the test script, which is this one here. Let's put it on the side. Wait a minute. Like that, and then we can put it on the side. And as soon as we run the command setAuthenticateCode signature, we get the signature down here. Okay, pretty long, right? It's a bit longer than usual because it contains our signature plus the signature from DigiCert, the timestamping. So you have two signatures in here. By the way, because I think it is not covered in the slides, why do we need a timestamp? The timestamp is crucial because if our code signing certificate expires, we still want our software to run. And maybe the software we have deployed, maybe you're maintaining an open source repository and a couple of thousand users are using your signed PowerShell module. So after 2 years, your code signing certificate expires. That's bad, right? If you don't have a timestamp, that would mean that the software stops working after 2 years. And this is extremely bad if you are in an open source environment and you don't know your customers, your clients, and they don't know you personally and can't contact you, right? So that means the software doesn't work anymore, it's an outage. So the timestamp guarantees that even if the certificate has expired, the software is still working and the signature is still valid, which is kind of a contradiction, right? So the certificate is no longer valid, but still the software runs.
It was signed in the window when it was valid.
Pardon?
It was signed in the window when it was valid.
That's it. It was signed. So why do we have this feature in the first place? First of all, to make the code run even after the certificate expires, but also if you revoke a certificate because you got compromised, then you know hopefully the date of the compromise. And then you can go maybe a couple of weeks back because you're not so sure when the compromise really has happened, and you revoke the certificate for a certain timestamp or for a certain date. The timestamp makes sure that the software signed before the breach is still working, but everything that has been signed with this certificate after the breach, even having a timestamp, does no longer work, right? So the timestamp guarantees that also a breach and a revocation of a certificate is handled kind of gracefully, so you're not disrupting the software that is already in a hopefully trusted way in the field. That's why we always want to use a timestamp if we are signing software. That's crucial. Okay, so that was the very easy process. And sometimes you have software that cannot be signed by PowerShell with set authenticate signature, but with some external tools like SignTool. And SignTool wants to access a PFX certificate. So what we have to do is we have to export the certificate, and then here it is. We have our code signing certificate as a PFX file, and this can be then used by the sign tool to do exactly the same like the set authenticate signature did. If I press F8, then we will see that the signature on the right-hand side will change. Here we go, right? So, and that's another crime, right? If you export a code signing certificate into a file, then you pretty much lose control because you have no control about where this file is being copied to, right? So if you have a certificate, then always make sure that the private key is not exportable. By the way, is it safe? If you have a certificate and the private key is marked as not exportable and it's on your machine, is it safe? Tools like Mimikatz have no problem exporting a non-exportable key, right? So if a machine is compromised, then all the certificates, all the private keys are also compromised, right? So even a non-exportable key is not a really security solution. Okay, so this is how stuff works locally. Don't do that. Only for testing purposes. Let's go back to the slides. Right, and here's the link to the material. Lessons from the demo. Better than bad code signing is no code signing, right? Because you're not increasing trust, you are actually decreasing it. And if your organization requires code signing, protect all your assets. And the most important asset is the private key. Actually, that's the only asset, right? The certificate, the public part, should be visible to anybody. Only the private key should be very well hidden. Never do code signing manually, but as part of a trusted release pipeline. Yeah. Why? So the customer 3 weeks ago that raised the question about execution policy and code signing is going exactly that way. They have a little script library, they have the code signing certificate on a network share, and every time they do a change to their source code files, they manually sign them. Does that scale? So what happens if the software is changed because the developer is on vacation, another person is changing the files, so then the question is, how do we sign the code? Where's the code signing certificate, right? How do we automate the process, at least so that all the 50 files get signed the same way and quick, right? So code signing should be something that is not slowing us down, that is not interfering in the release process. And if the release process is manual, code signing is manual as well, and always interferes in your process. Shouldn't be done like that. and never allow access to the private key. So we emphasize it here a couple of times because this is the #1 breach, that people get access to the private key and then they can pretend to be the author of a certain piece of software that they actually are not. So that's the lessons from the demo. Common code signing sins, pretty much the same thing, right? So loading a signing key on a thumb drive and distribute it with no control. It's all about control of your assets, right? Unfortunately, this happens pretty often, signing keys on a thumb drive. Using the same signing key to sign all files. And what we mean here is, rather than say in the next sentence, using the same signing key across different product lines and businesses. So if you have different pieces of software, different levels of criticality, different user groups that you target, different businesses with different severity, then use different code signing certificates, right? Because maybe the IT department, or you are maybe the identity department of the IT, and you sign your scripts with a certain certificate, but signing the scripts from the management, so let's say system management team, wouldn't be a good idea because it would give the user the view that all the software is coming from the same department, right? So also reflect by using a different code signing certificate the source of the code. Have no mechanism to control who can sign what. And that's extremely important. So if everybody has access, or let's say all team members have access to the private key, then you don't really know if the authenticity is as it should be, because the signing has maybe happened outside of the release process. And having no reporting capability to show who signed what and when. So this is also very important. If you have found a better way of signing, as we said, locally is not a good way. If we found a better way, then this better way needs to have a thorough auditing so that we know when our private key was used to sign what. That's very essential. Good. So how does signing work with Azure Key Vault? Not much different. So first, how to protect your assets. What we want to have is branch policies. By the way, no, I think something is not at the right space. Let's move it down. We'll come to that later. So, Azure Key Vault. This is how it works. Same thing, we have our code. The code is hashed, and the digest of the code is then sent to the Azure signing tool. Set authenticate signatures, the command that can only sign scripts with a physically available certificate and the private key, right? The Azure Sign tool is the proxy that communicates with Azure Key Vault. So we send the hash to the signing tool. The signing tool then sends the hash to the Azure Key Vault using the sign and the get function. So we don't access, the signing tool does not access the private key. It only sends the hash to the Key Vault and tells the Key Vault, hey, that's this thing that I want to get signed. Do it for me, and please send me back the signature. And the Azure Key Vault then uses the private key in the vault and the timestamp it received from Digicert or some other source and creates the signature and sends it back to the Azure Sign tool. So then we have our signature and we can stamp the file. Right? So the process is pretty much the same, just that our signing tool does not access the private key directly, it just delegates it to the Azure Key Vault. So how does it look like? Let's do the same in Azure Key Vault, and I have a plain Azure DevOps subscription, so there is no Key Vault installed, at least not for this demo. And let's hope that Wi-Fi works a bit better than yesterday. I'm connected to PowerShell Summit, okay. It doesn't. Yesterday, maybe this is still working. This is from a fellow attendee. He was so kind to share the hotspot yesterday, so that's another one. Is someone so friendly and can share a hotspot with me? But let's see, one more try. Something's happening. Oh, now it works, perfect. Okay, here we have the key vaults, and there is only my Summit 2025 test vault, but this is the one that we are not using now. So what we do is we go through the whole process of creating a vault, uploading a certificate, and using the certificate for signing. And the code is just this. So first thing is you need to install these two modules if you haven't done it already. You need to introduce PowerShell to your tenant by providing the ID. Then we are connecting to the tenant. Wait a minute, tenant ID, didn't I do that? Obviously not, okay. Here it is. Okay, we are connected. And then we are getting our subscription ID. We define the key vault name, the resource group, and the name of the key vault, coding signing demo. And then we are creating, before we are, can do that afterwards as well, we are creating an application because we don't want the signing to access the key vault with my personal account. It's running in a release pipeline or somewhere else. So we are creating an application, and the application has only the permission to access the key vault and call the signing operation. So first, we are creating the application. Then we are creating an app secret for authentication, which should be actually a certificate as well, but in this case, an app secret is just easier. We put the app secret into a file for later use, and then we are creating an app principal, which is actually doing then the work. Then we are creating a new Azure resource group, if it doesn't exist already. Obviously it did. And then we are creating the key vault, which takes 15, 20 seconds. And by the way, Azure Key Vault is the best example for something as a service, right? Previously, creating a similar service on premises was a very expensive and very hard thing to do, required a lot of knowledge and at least two people who really knew what they are doing. Otherwise, they would rather create a risk than a solution. And Azure Key Vault also comes with an HSM solution, so a highly secure way of handling certificates with no way whatsoever to extract the private keys, right? And usually an HSM was an appliance that you had in your data center, and this is the same thing, just as a service. Good, then we get the resource ID from the previously created key vault, here it is, and we allow our user to be in these, so the application to be in these roles. So the application that we created should be in Key Vault crypto user, Key Vault certificate user, and Key Vault reader. And we will see later that it was not a good idea to do that. And then we add this guy to all the three roles. And by the way, if you create a key vault, and even if you are the owner, you're not be able to interact with all the resources. So a key vault comes with a least privilege design. So even myself, I need to put myself into the key vault administrators to be able to upload a certificate. So this is what we do. Upload the certificate, or first making me part of the role, then define the password. And here we have a test signing certificate and a release certificate, and I am now importing. After authentication, I'm importing the certificate. Here we go. Okay, let's have a look at the key vault. Let's do a refresh. Here is the demo key vault. Let's have a look at the certificates. There is my Summit demo certificate. And if we go to the access management, then we have role assignments. Then I should be, myself is then the Key Vault administrator, here it is, and our application, the code signing demo application, is in the certificate users, crypto users, and the Key Vault reader. So everything as defined in the little script. Okay, any questions so far? Setting up the Key Vault is kind of easy. Good. Nice, let's go to the next script, which is actually doing the signing operation. So again, we specify our tenant. We connect to the tenant. I need to connect one more time because I am retrieving the application again, then the application secret, and then we use the application secret and the application ID to create a PS credential object. And this PS credential object then is used to connect to the tenant, to the key vault, right? Okay. So if you don't have the signing tool, the Azure signing tool already, this is the way how to install it. This is also the way to install it on the build agent. And let's use the Azure signing tool now to, again, sign our test script. So let's put the test script aside, just to see that something is happening there. And that's the wrong script, sorry. That's the one I wanted. And this is how we call the Azure signing tool, right? We can give it a description, but most importantly is, of course, the vault address. Where is my vault? What's its name? How do we authenticate against the vault with the app ID, the tenant ID, and the app secret? And what is the certificate that we want to use to do the signing operation? And where do we want to retrieve the timestamp from? And of course, what is the file that we want to sign? So if we highlight all this and press F8, then we've seen the signature was updated, and this signature is now coming from Azure Key Vault, and I can also get the authenticated signature from the script, and it works. It doesn't work on my machine because the certificate is not in the trusted roots, so the certificate chain is broken, of course, but the signing operation worked, right? So technically, it's very easy. It is just call the signing tool and you're done. In the whole process, what was the biggest mistake I have done already in the whole process? Is it still there? Yeah, the local PSX file. Why? Because I have uploaded it, right? So here is the code for creating the key vault again. And after creating the key vault, so this is creating the key vault, assigning the roles, and after the key vault was created, I was importing the certificate from PFX, right? But what is the other way of doing that? I mean, how should I get a certificate in the key vault if I'm not supposed to have it locally? That's it, yes. And that's the only chance nowadays of doing things. We will come to that later, right? So what we have done here is no longer a valid practice and doesn't work anymore, right? Luckily. Good. Any questions on the technical path that we did so far? Any questions on the code that we used to do the actual signing operation? Thanks for the key vault. Pretty straightforward, right? Good. So let's go back to the slides then. And still, I'm not sure where, no, somehow I messed up the order. Let's move it down here. Okay, no, that was the wrong slide. Again, this was our demo. This was our demo, signing with Azure Key Vault manually. And again, didn't I just change the order? Come on, you go here. And then we start the slideshow one more time. Okay, so I think let's give it up. Okay, let's follow the order. So first of all, what we have now is we have protected our private key in a way, but now we have a new attack vector, right? Microsoft Trusted Signing Service abused to code sign malware. This was just a couple of weeks ago, right? So if you do not control who can access your Azure Key Vault and who is allowed to do the signing operation, then you have almost the same problem, just at a different level, right? So be very crucial about who is be able to access your Key Vault, monitor the access, and always work with the least privilege concept. That's very important. To tackle the problem with the PFX file. So nowadays, we are only allowed to have EV code signing certificates, which means extended validation, coming from DigiCert and a bunch of other companies, right? What do we need to do in order to get a certificate like that? We need to send a certificate request issued by the HSM or Azure Key Vault to DigiCert. So what is that? Does this contain my private key? No, it does not. So the private key is generated in Azure Key Vault. Then we are creating a CRL request, a certificate request. This is just another digest of the private key. And then we send this to DigiCert. DigiCert builds the public part and sends the public part back. And then our Key Vault, we are merging the private and the public part, right? So the private part is never leaving Azure Key Vault. It is generated inside Azure Key Vault and stays there until you remove the certificate. But it will never get outside. And if you have a code signing certificate in the HSM feature of Azure Key Vault, there is no technical way of exporting the private key. There is simply no API for that, right? So this is then the way to not have you import the certificate manually, but rather completely generate it in Azure Key Vault. And that's the only way now to retrieve an extended validation certificate. So if you go to DigiCert and say, can I have a EV certificate on a thumb drive, please, by email, then there is no way for that, right? They will only allow this in that exact way. Okay, so again, how to protect the assets. First of all, FIPS 140 HSM, then timestamping, just to make the whole process robust. Centralized certificate inventory, so always make sure that you know what certificates you have and where they are. That's very important. And of course, monitoring. So somebody should get notified if I sign a script, not if I sign a testing solution, right? So if it is if my certificate is not very important and only used for internal purposes, then of course I don't need a thorough auditing. But as soon as my certificate is used to sign software that is hitting the market or is being used in critical infrastructure environments, then the usage of the certificate should be thoroughly monitored. Good. What is another way of protecting your assets? And this has nothing to do with code signing itself. This is more the code quality. All right? So if you are protecting the private key, if you have a least privilege model of dealing with your Azure Key Vault, but you are signing badly designed software, or the whole software release process is not secure, then still there is a high risk of signing stuff that you didn't intend to, right? So PowerShell scripts should always be in a Git repository in a transparent way, right? So the main branch should also be protected so that nobody can fiddle around with that. So we should always use pull requests in order to make a change and get the change approved by the relevant team members. So go through a little code review process to make sure that whatever we change in the code makes sense. So the PR should have, a pull request should have at least 1+ reviewer, and never allowed to approve your own pull requests, right? This is still a very common practice. And I mean, that's the ideal scenario. But if you are just a one-man show and you're working on your own project, then there isn't a review available, right? So then you always approve your own pull requests, but hopefully then the software is not so important that it needs to be signed and does some enterprise critical things, right? But as soon as software is critical, I would always demand for a second person to review my stuff and give me also a second opinion on things, right? So protecting the assets is also protecting what goes into the code signing process to get signed. Good. Then, how does code signing work in an Azure DevOps release pipeline? And for that, I would like to mention Sampler. Has anybody heard about that project? Only one. Okay. So who is designing and creating modules from time to time? Okay, then this is for you, right? So Sampler is a tool that, as mentioned, forces you right from the beginning to have a high code quality. So we are enforced to do linting. We are enforced to do pester tests. We are enforced to do a lot of stuff that you usually never would implement in a module that is not designed that way and forces you to do it. It runs all operating systems where PowerShell runs. So sampler runs on Linux, on macOS, on PowerShell Core, PowerShell, Windows PowerShell, and it runs on all common CI/CD products. So that means you get a pipeline that runs on Jenkins, on TeamCity. We have it on GitHub Enterprise and GitLab, and of course Azure DevOps as well. The pipelines just need to be tweaked a little bit. And it provides a single point of entry, the build script, and we will see in a minute what that actually means. And why is it so, why am I convinced that this is one of the best solutions? Because the DSC community has managed to handle about 100 modules with the sampler template, right? So we have standardized about 100 modules to give them the same pattern for build, release, and test. We don't do code signing in the PowerShell community, but this is a very easy thing to add. Okay, so these are the main features that sampler comes with. So what is important for code signing? Everything is important, but the most important thing for code signing is the publish mechanism. So the way it publishes software is standardized and automated. It enforces testing and code coverage. It enforces linting and versioning, right? So if you have a code signing process in place, but not an automated versioning process, then things might get also wrong, right? Because you may need to release the software one more time, but then it is already released with the version number. You release it again with the same version number, so you have a kind of duplicate artifact. Both artifacts are signed, so this is very bad, right? It completely ruins the trust. So versioning is also very important. And sampler is very extensible, so you can add your own tasks. And this is what we did here. We just added a task for code signing, which will be later integrated in the official sampler version. So how does it work? Let's demo that. And we have this little project here. Okay. And it has the normal structure of a sampler project. So it has automatic dependency resolution, which means that every time we build the software, all these modules will be downloaded automatically from an internal or external source. This is up to you how to define it. We have automatic versioning using Git version. We have a bunch of, in this case, only two, usually a bunch of tests that are making sure that whatever we have done in the code is actually doing what it should do. So testing the private and public functions. And we have a quality assurance that is just testing if the module is according to certain principles. For example, does every function has a help file or the comment-based help, right? Are there any violations of best practices like using plain text credentials? All this is tested here. And if one of these tests is failing, then the build stops because we don't want to sign software that is not according to our own rules. Of course, here we have the source folder with only two functions, one public and one private function. And if we want to build the module, the only thing we have to do is call the build script. You see, just the tests are finished. Code coverage is 100%, pretty unrealistic, but for this demo it works great. And now we should have a module available, get module list available, which is called as the project is, and here it is. So we have our module in the version 2.1.4 and a preview edition of that. Okay, so what happens if we do a change here? Then we just, let's make the indentation right. Okay, that's the only change we do. Then we go to our source control tab. We let GitHub Copilot generate a message. Fixed indentation, yeah, perfectly fine. We commit this and we sync the change. Was this according to the best practice? What do we do if we change something in a Git repository? Always branch, right. So for the sake of the demo, it was just quicker to do it in the main branch. Usually you create a branch, you do your stuff, you create a pull request, inform your teammates about the change, somebody's reviewing the stuff, and then if everything is fine, then you are free to commit into main and can delete your own branch. So what happened Well, what do you think? What happens in an ideal world after I have committed my change and the pull request was accepted? What happens in an ideal world? Pardon? Create a release. Do I have to do anything manually? Hopefully not, right? So, and what kind of release should we have released? A preview, right? So all the changes are resulting in preview releases. And if we are meeting as a team and we are going through all the changes and we are thinking, okay, we are ready for the next release, for the next real release, then we're using git tags to trigger the release of a full release. But all these little changes, all the accepted pull requests just result in pre-releases. Let's see what happens in Azure DevOps. Here is my pipeline. Pipeline runs, perfect. Pipeline is still in the build phase. So what takes the longest is downloading the dependencies. And sometimes Azure DevOps has a hiccup and doesn't give you the details. So the Azure signing tool has already been installed. This is just the call to the .NET exe. Fairly simple. Let's do an F5. Here we go. Still doing the, finished. Okay, so now we are building the module. So this is exactly the same thing that you have seen me doing locally, right? The build script creates the module. But additionally, what we do is that we additionally invoke the signing task after the creation. So there it is, sign. So now we call the Azure signing tool to sign the PSD1 and the PSM1 file. Yeah, there is the output of the signing tool. Perfect. And then we're done. So the building and the packaging worked. Next thing is we are testing our software on Linux and on Windows, PowerShell and PowerShell Core. So this runs in parallel, and afterwards we are doing the deployment. So the deployment will exactly look like what I have done this morning. So let's go to the last run of the pipeline, which is here. So this is how it looks like. Afterwards comes the test and then the deployment. And the deployment creates a new release on GitHub plus a new release in the PowerShell gallery, right? So if we go to PowerShell gallery and search for my test project, how is it called? Like that. Not exactly. Then, why do we have two? Interesting. Here we go. So preview 1 was released this morning, 2 hours ago. And I have one download, interesting. Who's downloading that stuff? Yeah, and in a couple of seconds, we should see a second release, right? Without any human intervention. It was just following the normal pull request process, and all the rest is being taken care of, right? So if you want to do code signing, then use the tools available in the PowerShell community, because usually it is speeding things up. Not at first. So learning sampler is a learning curve that is a bit steep, so it takes you maybe 2-3 days to get accustomed to that. And if you have been accustomed to that and have found all the little tweaks and the configuration files, then it is definitely a solution that by your own would take a couple of months or years to develop. So the sampler module is kind of gathering the experience as best practices in the PowerShell, or of the PowerShell community of the last 7 years, I would say, right? It combines everything that the PowerShell community has learned from software development processes, and sampler puts it into action. Okay. So this was how to use sampler to do code signing in an integrated release pipeline, right? And I think setting this up for one of your as a little testing project takes you not more than half an hour, right? So very easy. The most difficult part with sampler is writing tests, because it requires you to write tests. So this is usually the first thing that people remove. They remove the requirement of writing tests because it can take much more time to write a test than the actual code that you wanted to do, right? Good. So, Do's and don'ts in summary. Never allow access to the private key, once again, right? Because it happens too often. And because of that, never do any local signing. It is not a real secure way, and it only mimics security, but is actually the opposite. Use branch policies to enforce a solid code review and approval process, right? If you have garbage that you are signing, then the result is also garbage, right? Don't sign code manually, of course. And release your software in a CI/CD pipeline that automatically signs the artifacts, right? Anything else is usually error-prone and makes life not easier. Yeah, so the bottom line is protect all your assets. So even if you have protected the private key in an Azure Key Vault, then now your asset to protect is the Key Vault itself, who will be able to access it. And by the way, one last demo is, and I did the mistake when preparing the stuff here. We have, do I find it? Connect. Oh, I don't find it. But this role here, the Key Vault Certificate User role, allows you to extract the private keys. Right? Be very careful in assigning roles to the application, because if you assign the wrong one, then maybe you're even more unsecure than you expect. Right? So very important to make sure that the right roles are assigned. And we have a bunch of resources in the slides, and these resources might help you to also adopt that. Question, please.
You just mentioned that there is a particular role that allows to exploit private key, but earlier in the talk you mentioned that it is not possible.
If you have an HSM, if you have a code signing certificate generated on the HSM, and then it's impossible. But this is the feature that I have not used here because I didn't want to spend a bunch of bucks just for the sake of the demo. Yeah. Any other questions? Another one, please.
So what about on-premises PKI? If we have just a private PKI infrastructure, is there anything wrong with that?
HSM. You buy a hardware appliance, the hardware appliance talks to your on-premises PKI, so it's the same process like Azure Key Vault and DigiCert or another vendor, just locally in your organization. So without an HSM, it's always being not really secure, right? Please.
It's a good solution that mirrors the Azure sign tool, where it's I'm sending you my code, you go talk to the PKI, and then you give me back. That is Azure.
What do you mean?
The Azure sign tool. It's just taking your code.
Yeah, not the code, the hash of the code. Yeah, it takes the digits of the yeah.
And then it's coming back and giving you a
Yes.
the signature.
Yeah.
Have you seen another tool that isn't Azure specific?
I mean, it's just an API you're calling to. So if you want to do everything by your own, or if you're not happy with the Azure signing tool, you can talk to the REST API directly. But why? Pardon me?
Don't have Azure.
Ah, okay. But then maybe you use Amazon. Then I think Amazon comes up with a similar set of tools.
But like for on-prem or something, right?
Yeah, no. If you use an HSM, for example, then they come with their own API and with their own set of tools, right? But then you can't use Azure Key Vault. Yeah. Okay. Okay. Thank you very much.